Hello everyone. In today's lecture, we'll be looking at how we can compare means and do independent sample t-test, which is a type of compare means in SPSS software. Before we go into understanding the concept of when to use compare means and the concept of independent sample t-test, and few concepts related to independent sample t-test that we will see in the output window. First of all, we'll look into the hypothesis testing, a few concepts like the errors which we might perform while we are trying to perform hypothesis testing. So we know that from the previous lectures that hypothesis testing consists of two hypotheses, the null hypothesis and the alternate hypothesis. So the null hypothesis states that there is no effect present between the two variables under study, namely the independent variable and the dependent variable. The other kind of hypothesis that we write is the alternative hypothesis, which states that there is some effect present between these two variables, again, namely the independent variable and the dependent variable. So this is what are the two hypotheses that we write or we state whenever we are performing the hypothesis testing. Suppose we have a scenario where we are interested in assessing if there are differences in the mean income between the genders, male and female. So in such a scenario, how do we write the null hypothesis and the alternate hypothesis? So for this scenario, the null hypothesis can be written as there is no difference between the groups male and female with respect to their mean income. Whereas for the alternative hypothesis, we can write that there is a difference in the mean income between the groups males and females. So for different scenarios, depending upon the scenario that we have in hand and depending upon the independent variables and dependent variables we want to study in that particular scenario, we can write the null hypothesis and the alternate hypothesis. Now, when we perform hypothesis testing, we tend to perform a few kinds of errors. So what are these errors? These errors are known as your type 1 and type 2 error. So this type 1 and type 2 error, we form a quadrant having 4 boxes, and on the x-axis we state that the null hypothesis is true for one quadrant and null hypothesis is false for the other quadrant. And on the y-axis, we'll write null hypothesis is rejected and null hypothesis is not rejected. Now, based on these only, we will be having the 4 quadrants. So whenever the null hypothesis is true, so from the, since it's not possible in real scenario to study the whole population, so what we do is we take a small sample of the population, we study that particular sample in order to understand the characteristics of the population and then try to generalize the results that we have obtained from the sample onto the population back again. So if we have a fair idea of what we want to prove, so suppose now if we take the scenario in hand, the difference between the mean income of male and female, if you see in the population, we will say that there is a difference between the male and the female's mean income levels. So now the null hypothesis is not true over here. But while testing, if we prove it or if the sample that we're testing out proves that the null hypothesis is true, that there is no difference between these groups, then we are performing the type 2 error. So here, the null hypothesis is false, meaning there is a difference between the groups mean income between male and the female. But the sample which we are doing hypothesis testing for proves that we cannot reject our null hypothesis. There is no difference between the groups. So if you see in this quadrant over here, when null hypothesis is false in the real scenario, but while testing, we are not able to reject it, then we are performing a kind of error which is known as the type 2 error, or also it is known as the false negative. Now, there's a second error, which is the type 1 error. Now, when is this happening is when the null hypothesis is true in a real scenario. So there is no difference between the groups. That is in the real scenario, that is what is happening. But we are rejecting the null hypothesis and accepting our alternative hypothesis based on the sample that we have collected. So what is happening is that even though the null hypothesis is true in the real scenario, from the sample, the hypothesis testing that we are performing, we are going ahead and rejecting it because that is what our sample hypothesis is saying. So we are performing a kind of a type 1 error, which is also known as false positive. So these are the two kinds of error we perform. The other two cases in the quadrant are the correct decisions, because whenever the null hypothesis is false in the real scenario and we're also rejecting it, that is a correct decision that we have done. We have to reject it because it is false. And the other scenario is the when null hypothesis is true, but it is not rejected. That is, since it is true, we cannot reject the null hypothesis. So again, it is a correct decision. So we just need to remember that we should minimize performing this type 1 and type 2 error. How we can do this is by increasing the sample size. More number of samples if we taken into consideration, then we'll be able to generalize the findings of a sample onto the population. So hence, this is the errors that we need to avoid. Now, moving on to the topic of compare means. Now, when is the compare means done? Compare means analysis is performed when your independent variable is categorical in nature, that is either nominal or ordinal, and your dependent variable is continuous in nature, which means it is either ratio or it is scale data. So when your independent variable is categorical, dependent variable is continuous, then only we go ahead and use compare means. Now in compare means itself, we have various statistical techniques in SPSS software. There are 6 statistical techniques which we can use for comparing the means between two groups or two variables. The first one is your means. Now means, as we know, it calculates the subgroup means and the related statistics for dependent variables within categories of one or more independent variables. So it helps us to calculate the mean value. The next one is the one sample t-test, which tests whether the mean of a single variable differs from a specified value. So here, for example, a group is using a new learning method. So here, compared to the traditional method, we are segregating a small group and trying to implement the new learning method and trying to see whether if we implement this new learning method, will it be effective or not and increase the school average performance or not. So therefore, this kind of analysis where you want to test whether the mean of a single variable differs from a specified value, then you perform the one sample t-test. So you're specifying a certain value and you're checking whether the mean of the variable that you want to test is different from that particular specified value or not. The next one is the independent sample t-test. This is a test that we'll be frequently using. So here it tests whether the means of two groups differ on a continuous dependent variable. So for example, on the scenario that we have seen, the dependent variable is the mean income and your independent variable is the gender, where we have two categories, male and female. So when we have two groups in the independent variable and the dependent variable is continuous in nature, then we use the independent sample t-test. Summary independent sample t-test is also similar to your independent sample t-test, but it uses summary statistics to test whether the means for two groups differ on a continuous dependent variable. So more summary statistics are given over here in your summary independent sample t-test. So we'll also see how we can do the summary independent sample t-test in the upcoming lectures as well. The next one is your paired sample t-test, which tests whether the means differ for each group under two different conditions. So for example, post and pre-intervention. For example, you have a drug which you want to test and see whether it is effective on the patient or not. So you will see the effectiveness of other drugs in order to improve the health of the patient. So that is pre-implementing the new drug, and then you will administer the new drug and you will see the effectiveness of that drug on the health of the patient. So it becomes post intervention of that new drug. So pre and post, both you will be recording the data and then you will try to test and see the means whether they differ or they remain the same or not. And the last one is your one-way ANOVA. Now this particular test will test and see whether the means of two or more groups differ on a continuous dependent variable. So one-way ANOVA is mostly used when your independent variable, which is categorical in nature, has more than two groups. Okay. For example, you have gender itself, male, female, and others. Now, if you have in your questionnaire male, females, and others, it becomes three groups. Since it becomes three groups, you cannot use independent sample t-test. Then you will be using the one-way ANOVA. So these are the various statistical techniques for compare means in the SPSS software. In the next class, we'll be focusing more on the independent sample t-test. Thank you.